Hello, everyone. This is Mr. Parks. Welcome to this first week or 0th week of our Computing Fundamentals course. Turns out that this first week is going to be a short week for us since the semester begins on the same day as our meetings via Teams. We really want those meetings via Teams to be in the middle of our lesson week and not right at the beginning of it. You need to have some chance to look over the material and bring your questions to our meetings. So to make up for the fact that this is going to be a short week, I thought I would walk through some of the material that's going to be in the lab, and maybe that will help speed things along. By the way, I would suggest that you do the lab before you do the quiz. The math that's behind the lab will get your brain working in the right direction to do the quiz. I think that'll be good preparation. So let's start with the game of NIM. If I can figure out how to, oops. Here we go. Here's our lab, and it's the game of NIM. The purpose of the game of NIM is to make your opponent pick up the last stick from a pile of sticks. So if the pile has only one stick in it and it's your turn, you have to pick it up and you lose. On the other hand, if you can arrange the pile so that only one stick is left after your turn and your opponent has to pick up a stick, but there's only one to pick up, your opponent loses. And you can pick up 1, 2, 3, or 4 sticks at a turn. And these are the rules of the game. I won't go through them in detail, but I'll just say that if there's only one stick in a pile, that's a bad pile for you because you have to pick up at least one. There's only one to pick up. You're going to lose that game. And what we're going to be doing throughout this analysis of NIM is determining what's a bad pile and what's a good pile. And we see down here from this table that if the pile you have to deal with has 6 sticks in it, there's really nothing you can do to win that game, barring your opponent screwing up somehow. And this analysis, why is a pile with 6 sticks a bad pile? And here's the analysis of everything that can go on when your turn has a pile of 6 sticks in it. On the other hand, this is an analysis with when the pile has 7, 8, 9, or 10 sticks. Long story short, if a pile has 7, 8, 9, or 10 sticks in it, you can pick up enough sticks to give your opponent the bad pile of 6 sticks. And 11 sticks is also a bad pile. And here's the analysis. It's much like the pile of 6 sticks plus an extra pile, plus more, and more turns are going to be going. So we've said that a pile of 1, 6, 11, or 16 sticks is a bad pile. Actually, we didn't say 16 was a bad pile, but we'll throw in that one for free. So you want to identify the next 2 piles that are bad piles. So we would have a sequence 1, 6, 11, 16, and then 2 other numbers that represent bad piles. I will just point out you might want to look at the relationships between each pair of these numbers, between the 1 and the 6, 6 and the 11, excuse me, and the 11 and 16. to pick out what your next two numbers are. Then we come to another discussion about, okay, here's a sequence of numbers, excuse me. How can I come up with a formula, in this case, that's this one, to enumerate these sequences based on some independent variable like 0, 1, 2, 3, and so forth. Probably computer scientists would refer to that as a key, whereas a mathematician would call it an independent variable. That's a topic for a different day. But if my variable here is 0, 3 times 0 is 0 plus 1 means that the element 0 of my set is 1. If I take my independent variable here is 1, 3 times 1 is 3, plus 1 is 4. And so element 1 of my set, my sequence here, is 4, and so forth. So the challenge here is to determine, well, here we are showing how you would calculate if 321 was an element of this sequence. Here we are showing how to calculate if 205 is an element of this sequence, both of them based on knowing and manipulating this formula. Now, problem 2 is not about the game of NIM directly. We have another sequence, and again, look for the relationships of the pairs of each element, the relationship of 1 to 5, the relationship of 5 to 9, and so forth. And we're given that formula. Notice that the independent variable here starts with 1 instead of 0 in this case. So if k is 1, 4 times k is 4 minus 3. Element 1 of that sequence is 1. If k is 2, 4 times 2 is 8, minus 3 is 5. So element 2 of that sequence is 5, and so forth. And here you have to determine are 195 and or 237 a member of this set. And you'll be doing the kind of analysis that we did up here. Now, starting with problem 3, we get back into the game of NIM, and we're asking you to come up with the formula. Your independent variables are going to be 0, 1, 2, 3, and so forth, as high as you want to go. And 1, 3, 6, 11, and 16 are the bad piles, the numbers of sticks in a bad pile. So here we're asking you to come up with a formula based on this sequence of values, starting with an independent variable of 0, and come up with a formula for the bad piles, which would be the elements in that sequence. And then we'll ask you if 286 and 285 are good piles and bad piles. So now we've sort of blitzed through the game of NIM, how it's won, what it means to lose, and we've identified indicators that you're going to lose the game because you have a bad pile unless your opponent does something stupid, which you really shouldn't rely on, I don't think. And we then taken a sequence of integers, numbers, and reduced them to a closed formula based on independent variables starting at 0 or 1 and increasing by 1 each time. And Hopefully that will give you a leg up on the lab. And again, the lab will get your brain working in the right sort of math context or math thoughts to take on the quiz. I hope that helps, and I look forward to seeing you on Thursdays. Bye.